Let's talk about isothermal expansion. Now we're in our constant temperature situation. So I think you already know what the answer to this is going to be, but we'll ask it anyway. Is it possible to have heat transfer when there's no changes in temperature? The answer is yes, but once again, it also seems very confusing because we described heat as being the flow between two differences in temperature. Or we think that the only reason heat would flow is because there's a difference in temperature. Okay? So here, you have to suspend your disbelief for a little bit and imagine that our heat bath is kind of infinite and it holds temperature constant in our system, which is just the piston. It's going to keep temperature constant in the piston. In reality, this whole heat bath would probably have to be on a heat plate that's constantly supplying heat, but again, think about what we defined our system as, okay? Just the piston. Pistons at constant temperature, okay? Our gas inside there. So, constant temperature of the system maintained by the heat bath means dT 0. We said we're talking about we have an ideal gas inside of our piston, so if du is equal to 3 halves nr dt, and dt is 0, du also has to be 0. If there's no change in temperature for an ideal gas, then there's no change in internal energy for the ideal gas. Because the measure of internal energy was just kinetic energy, which was just temperature. Our first law becomes something like this, okay? Because the du piece is 0. So du equals dq plus dw. We can move dw to the other side, and now we have heat is equal to negative work. Basically what this means is that all of the work done to expand the system or push up the piston was supplied by the heat. All the heat flowing in went to moving the piston, and none of it went to changing temperature. Okay? And that's how you can have heat flow that there's no change in temperature as a result of the heat flow. Okay? Instead, it all went to green. U stays constant. So even though the energy of the system, du, is 0, this expansion, when I compress this, and I let it go, it is going to expand spontaneously. I would expect that to happen. But I don't have any negative change in energy to indicate, to kind of cue to me that I should expect spontaneity. So the driving force for this change is an increase in entropy. Getting more entropy by letting that gas expand into more space is what really fuels this, and that's the basis of Wednesday's discussion, is increased entropy, increased disorder.